Today we're going to take a look at Triangle Midsegment. This is from Chapter 5-4, and to try and keep it short, I'm going to get right to it. Suffering from a bit of a cold this weekend. I think y'all noticed that last class. Okay, this is straight out of the book, Example 1, page 322. I kind of did this in class as well, but I didn't actually, we started off with the midsegment. Here we're going to have to find it. So what we're going to do is we're just going to find a midsegment of just one of the sides and just explore that one. So what we're going to do is we're going to find the midsegment to this one and this one right here. So we're going to start off by finding the midpoint. So the midpoint is nothing more. Let's do the midpoint of HG. And we're going to add the two x's together. -5 plus -7 all over 2. We're taking the average. That's going to be -12 over 2, which is equal to -6. All right? And we got to do the same thing for the y's. 6 plus a -2 all over 2 is 4 over 2, which is equal to 2. So our midpoint is -6, 2, right here. And we're going to call that K. K is going to go right here. And I guess I could have squeezed that in a little better. We're going to call that -6, 2. All right? Then we're going to find L, which is somewhere over here. And we're going to do the same thing, add our x's together. So we're going to do -5 plus 1, so -5 plus 1. I know it bleeds a little, so that's -4 over 2, which is equal to -2. So our midpoint is going to be somewhere right around this line right here. That makes kind of sense. And then I'll write -2 right here. And let's find our y coordinate. 6 plus 2 is 8, so we have 8 over 2, which is equal to 4. So our point is 4. So our midsegment is -2, 4. Now what we want to do, well, we don't know if that's we just found the two midpoints. What we're going to do is, one, determine if they're parallel. So we're going to find the slopes of KL, and we're going to find the slopes of GJ. Looks like they're both positive, and it's a mild slope, so it's probably going to be a fraction. And with a coordinate grid, it's easy to find. We just go count up. So I'm going to count up 1, 2, so that's a +2. 1, 2, 3, 4, and that's +4. So 2 over 4, which simplifies to 1/2. Well, I better get a 1/2 over here. And actually, I'm going to expect a 4 over 8. Well, let's see what happens. Let's go 1, 2, 3, 4. So yeah, we got a +4. We go 1, 2, 3, 4, 5, 6, 7, 8. And we got a +8. And that makes sense. From -7 to 1 is 8. Difference of our y's over the difference of our x's. So we also have 4/8 or 1/2. So these two things are parallel. So what we want to do now is find the distance. And I'm going to pick blue to do that. So we're going to use the distance formula. And the distance formula, let me recap real on that. It's delta x, difference of my x's, plus delta y, the difference of my y's, all squared under a radical sign. So let's find distance of KL first. dKL. And what we have now is the difference of our x's. From -6 to -2 is 4. 4 squared is 16. Plus, and from 2 to 4 is 2, so 2 squared, 2 goes right in there, is 4, and I get radical 20. When we break up radical 20, again, a review, this is nothing more than 4 times 5. Square root of 4 is 2, so we get 2 radical 5. Well, I'm hoping to get 4 radical 5 when I do GJ. So let's find out if we do. dGJ. Okay, let's find the distance of that. And from -7 to 1 is an 8. We throw 8 right in here. That's squared. That's 64. So let's take a look at our y. So -2 to 2 is 4. We throw a 4 right in here. So 4 squared is 16. And we get 64 plus 16 is radical 80. That's nothing more than 16 times 5. And that is equal to 4 radical 5. So we've proven the midsegment theorem, basically. We found the midpoints of these 2 points by using our midpoint. Then we found the slopes. What we have is 1/2 and 1/2. Then we went and used the distance formula and found that this is 2 radical 5 and this is exactly twice that, 4 radical 5. So let's see how this works in additional problems. So I'm going to go back to purple, hit that, and next. So let's take a look at an example. This is a very typical example involving algebra. My sniffling is getting to me, so I'm pausing now and then. What we have here is we know this is a midsegment because we have a midpoint right here, because these are equal. We have a midpoint right here, and we have a segment joining them. That's midsegment. Using our theorem, we understand that this right here is exactly half. This is exactly half of this length right here. So there's a couple of ways we can do this. We do 5n is equal to half of this. 5n is equal to half of that is 4n plus 5. Or we can double this, because that's half. To make it equal, we have to double it. We can do 10n is equal to 8n plus 10. Either way works. So let's go ahead and do this one right here. And we just subtract 4n, so we get n is equal to 5. And let's double check our work. Put 5 in here, I get 25. Put 5 here, 5 here, wait a second. Yeah, we get 25. Put 5 here, we get 50. 50 and 25 is good. That's half. Alrighty, let's take a look at a far more complex problem. And if you could do this, you are on target. We're not actually going to find everything. I'm just going to find some of the angles, because this could take a little bit of time. So first of all, we're going to label. I got 6x plus 4. So 6x plus 4 for LO. That's this whole thing right here. LM is 4x. So we got 4x here. I might as well go ahead and, well, I'll wait for that. MP is 3x. NO is 42, so this whole thing is 42. And notice how I just didn't write a 42 over here, because that can make an illusion that just one of these segments is 42. And I'll hold off on the angles just yet, because I might have to erase, because this is going to get a little busy. So we'll find the angles shortly. Well, we're going to use the midsegment. When I look at a problem like this, I want to look at what's parallel. This is parallel to that. And this is going to be the easiest one to find, because 3x is going to be half of 42. Half of 42 is 21. We just have 3x is equal to 21. X is going to be equal to 7. I take that and plug it all in. Well, we got 4x here to also, because it's a midsegment. So I put in 7 right here, so this is 28. This is 28, so this whole thing is 56. And we put in 7 right here, 42 plus 4. Or is that a minus? That is a plus. That is a plus. I can't even read my own writing. So this is 48 right up here. Okay. That means this is 24, and this is 24. And guess what? This is half of the whole thing, or equal to one of these segments, so this is 24. See what's going on here? This is 28. This segment right here. Half of all this, 28. So we found all these right here. Of course, this is 21 right here. And so we found all our segments. Now the angles are going to be a bit more trickier. So what we're going to have to do here is, actually I'm going to go ahead and clone this page. And let me clone. We'll go here. I'm going to erase. This is all angles. So let's get rid of all the sides and take a look at the angles. Now I'm not going to do all the angles. NO, let's see, let's find our angles. Here's one here, and here's one here. LPM is 52, and angle L is 44. So when we do this, we're going to be looking for parallel lines and the transversal, and looking for alternate interior, same side interior, corresponding, and things like that. Well, one thing that we can do, since we're going to be looking for all the angles, even though I'm not going to do every one, you can do that angle game later, is I have this angle, so I can find this angle right here by just simply subtracting it from 180. So that is 96, so this is going to be 84. So this is 84 right here. And we also have corresponding. This is parallel and this is parallel. Actually, let's find this one right here. We're going to have it corresponding right here. See how these two lines are parallel? I'll mark the parallel lines here. We have parallel here. We have parallel here. And we have parallel, let me find, let's do it in red. 1, 2, 3. 1, 2, 3. And we just start doing our angle game. Well, I can find all kinds of things right here. Well, if we have 84, this is going to be 84 because we have alternate interior right there. Alternate interior, because we have two lines. See the two lines right here? And the transversal, alternate interior angles. And that's how would we go about doing this. And we can play more of the angle game because we can look at this angle right here. This big angle has to add up to 180 minus 84. And we also have 44 here. This whole thing right here corresponding has to be parallel, parallel, transversal. That's going to be 44 over here. So it all adds up, and this whole thing I have to add up to 180. So the angle games, and then you can find these triangles here by using your triangle addition postulate. Okay, triangle sum. So that is pretty much it for this. I am going to upload this and take a little bit of a walk with my dog, I think. And it's been a sad weekend at this house. This is one reason why I haven't done anything yesterday. Our cat is no longer with us, and we're going to miss Scooby a lot. We have a very sad household. Very sad. He lived a good life. We rescued him from a German barn. He was a barn cat and only spoke German. We had to teach him English after we got to the U.S. And he started to get better at it. He still had an accent, but we're going to miss him. We're going to miss him a lot.